So thank you, Seth. Again, I'm very happy to be here today and present a topic that is very important and challenging, how to improve adoption of NLP deep learning in the industry. Let me, okay, I have some announcement. Okay, so a little bit background on myself. In my former role, I have been with NICE System for 18 years and led the speech text analytics research group. We were the first company to deploy speech to text, emotion detection, and voice biometric in call center. You're probably familiar with the statement, your call has been recorded for quality assurance. Most likely it's been recorded and analyzed by NICE System. In the last 7 years, I've been with Intel, leading the research in applied NLP, innovate for our products, collaborating with the research lab in academia, and explore a new feature that disrupt hardware and new architectures. So the agenda for today, I'm going to speak about two main challenges that related to increased adoption of deep learning NLP in the industry. So the first one, again, there are probably other challenges, but those are the main one. The first one is efficiency. I'm going to give some background on recent progress in large language models. They describe some popular methods for compression and efficiency with few real use case examples. And I also would like to promote a workshop that I'm part of the program committee. It's going to be in November, Sustain NLP. It's also about efficiency and robustness of NLP in the industry. The second challenge is, if we will have time, is about extensibility, basically address new domain with limited data and minimal supervision. And I will focus on our aspect-based sentiment analysis application as an example, which actually offers some weekly supervised workflow to handle extensibility challenge. So yeah, so if you Google 2 years ago, BERT, you will most likely see the following results. But what is nice is that a few months later, if you do the same, you probably see strange things like pre-trained bidirectional and language models. And really, so what has actually happened? So BERT was first introduced in October 2018 by Google AI. In a few months, it's become the standard NLP infrastructure. NLP-based system, as we know, break all the state-of-the-art, result in many NLP tasks like Q&A, name entity recognition, NLI, and more. So, give you some. So actually, what is BERT? Just put us in the same page. If we see the diagram of BERT on the right side, you can think of BERT as a kind of a black box, or in other words, encoder that get the input text, sentence, and output some compact representation, which is a kind of a feature set that represents the sentence. This specific model was trained in unsupervised way, targeting specific task, which called mask language model, which means that it was trained to find missing words in a sentence. And it turned out to be that the resultant representation is very useful to many different tasks. For example, it can be any classification, sequence tagging, and other. The two main advantages of BERT that I think that are actually very dramatic and made a huge impact on the industry is first the efficient transfer learning. So with that, you actually leveraging a large model that was pre-trained on a very generic task like a masking language model, and you actually use it for other specific tasks using small amount of data. For example, like sentiment classification. And this is quite dramatic because you don't have to train from scratch for your specific task. You just need to do some, you need to extract features with BERT and do fine tuning on your specific task with something like a very simple classifier. And I will talk about it more. The advantage is that you can have high accuracy even with smaller amount of data. And this is very critical for the industry. The second advantage is, of course, we know it's more contextual representation. So it's have a distinct representation for riverbank or investment bank. So in those cases, you have different representation of the World Bank. And in addition, as you know, BERT is quite large. It's the base BERT is 12 layers, transformer layers, and the large model, the large base is 24, with more than 100 million parameters for the base and more than 300 million parameters for the large model. So the pre-trained language model as BERT have kind of become extremely large and deep, and have recently achieved state-of-the-art result in many NLP tasks, and larger is better. And what you can see actually here in this figure, you can see the BERT large, actually with more than 300 million parameters, just kind of the start of the essence curve. And you can see followed by other models like GPT-2 with 1.5 billion parameters, and NVIDIA Megatron with over 8 billions, and T5 with 11 billions, and then Microsoft with 17 billions. And as you know, recently GPT-3 was released, and it has more than 150 billion parameters. However, those generic pre-trained models come with a cost, of course. And the challenge is the number of parameters and depth of the models bring a heavy competition burden, of course, for if you are taking the model into production. And of course, is not efficient in terms of energy. And the challenge eventually is also to run training and then run inference in production. So the question is, what the kind of the research community is also struggling is how do you take those models, those monster models into production? And this is kind of what I'm going to review in the next few slides. I'm going to present a few of the more popular methods to optimize BERT in production. And also we'll focus on some very exciting work that you actually can deploy BERT in a very efficient way using distillation methods. Okay, what we see also in the research community, I can say in the last few months, we see that there is a kind of a trend in research that trying to more going from accuracy to efficiency. So it's kind of the opposite trend or the opposite curve that we saw in the last slide. So starting from BERT, you see the first model was Distillation by Hugging Face with 50% of the number of parameters and increased speed up. And then we saw followed by other models like Mobile BERT, Tiny BERT, and Albert, which actually are much more efficient and has less parameters, and of course also can speed up your performance doing inference. And I will talk about the methods that actually they are using. So A few vectors for optimization, just to give kind of an overview of the well-known, more popular methods to optimize BERT or large model, or even even in computer vision, they're quite relevant. First, it's quantization. So if you have a larger bit quantization of your weights, if it's 32, and you actually convert it to 8 bits, so of course you gain compression. Other method is pruning. Basically, you take your weight or the structure of your models and actually exclude some of the layers or exclude some of the weights, or even do some pruning for specific weights in your model. Early prediction of samples, which means that you can, during inference, you can actually exit early. So you don't have to do all the calculation. For example, if you BERT 12 layers, you don't have to run the full 12 layers to get good results. So this is also something that we saw emerge in the last few months. There was quite exciting results. Sharing weights. So instead of having distinct weights for each layer, you can share weights between layers, and this is also give you a much more efficient representation. The most kind of popular methods is distillation. We'll talk about it more in the next few slides. And last is basically replacing transformers with other more efficient model or a subset of networks using methods like NAS, which is a neural architecture search. So basically, try to search for a much optimal network with the same performance. So let's start with quantization and one simple example. So as I mentioned, if you quantize your weights from 32 bits into 16 bit or 8 bits, you basically gain compression. With 8 bit, it's 4x compression. And you, of course, must preserve minimal loss in accuracy. And again, this is actually doable. And there are many works that show that you actually can go down to 8 bit and get the same accuracy as the 32 bit representation. This is one example for one of game platform providers that actually did some optimization using very simple methods to scale up BERT on CPU on the server. They did some nice representation of, they use Distillation from Hugging Face as the base model. Then they also set dynamic shape input. And last, they did quantization to 8 bits. And again, more than 30x improvement in terms of inference speed, and also reduced the latency from more than 300 milliseconds to less than 10 milliseconds. So this is one example of how you actually can deploy quantization in production. Second method is pruning. And this is also an example from a paper called Pullman BERT. And what they try to do is basically trying different tactics in order to exclude layers from BERT. And they try to reduce to exclude the top layer, the even and odd alternate dropping from the models, combination of those techniques, and do some symmetric dropping and bottom layer dropping. Eventually, they found out that just even reducing the or prune up to 9 of the top layers from a 12-layer representation actually can give you a good performance, and even less than 3% compared to the BERT base with the 12 layers. And this is, of course, can be specific for a task. So this is also something that you can actually do to reduce the size of BERT and get the same performance. And with distillation, I'm going to give you more examples. So distillation is the most popular and successful way to optimize the large transformer neural net. The teacher is the large model in this figure, and the student is the small model that we are targeting to run in production. So we have the basic BERT, and we also have some kind of a small representation of BERT. It can be, for example, instead of 12 layers, 6 layers or 3 layers. So just as a kind of in high level, so the student sees his teacher, in this case BERT, as a black box, and has only visibility to the input text and the output labels, and also some internal features like logit or the internal embeddings or the attention that we can extract from BERT. So what the small model is trying to do is adapting its internal parameters in order to minimize some function loss. In most cases, it can be something like a MSE to mimic his teacher output given the same input text. So basically, we try to steal or distill information, knowledge from BERT just by mimicking the output of BERT. So the result is a smaller model, hopefully with the same performance as the large model. And this is something that we, and I saw in the industry, that it's possible and provide a very good performance. To give you two examples related to distillation, to give much more details. First is the naive approach. I call it naive approach. Also, it was presented at last ICLR 20 and we won the Best Paper Awards. It's called a Thieves on Sesame Street. What they actually tried to do, the author showed that it's possible to steal the weights from a remote BERT service by just sending text input and receiving the labels via secure API. So just by looking on the output of BERT and of course knowing what are the input text, they were able to reproduce or steal BERT models. And this is quite exciting results. In a similar way, you can do distillation not just to smaller BERT, but also, of course also to other smaller architectures like LSTM or CNN, and even of course a smaller BERT. What you see here in the picture, this is a specific use case for sentiment analysis. You see on the left side we have unlabeled sentences. The movie was good as the book, and we pass the unlabeled sentences via BERT and utilize the hard label output, which is in this case positive or negative. It's also called pseudo label because we are labeling the unlabeled data with some model. And of course, with additional training data, if it's available, if you have some annotated data, you actually can train the student model. So basically, you have two loss functions. One is from the pseudo labelings, and one is from the annotated labels. You can think about it as a kind of a way to augment. If you are training a small model, you can think about the naive approach as something like augmenting your training data. So you have some annotated data, but the way to augment your data and have more data for training your small model is basically by using BERT to annotate new data or unlabeled data. So in this case, you're actually accumulating a large amount of data, which is some is annotated and some is actually pseudo annotated. And actually it gives very, very nice results. And they show that it can actually mimic completely the weights of BERT, and it also works for other small models. The second approach is actually from the original paper by Hinton about distillation. And in this case, you are not trying to steal or to augment your data with hard label or pseudo labeling. You are trying to mimic the output distribution of BERT. In this case, it can be something like a logit. What is the student trying to do is mimic his master probability distribution. And you can see here, we're calculating some mean square error between the distribution, and this is part of the training of your student model. Intuitively, you can actually think about it as you learn the teacher output distribution over classes, and this provides more training signal than hard label or the one hot label, as we saw in the last slide. Actually, Hinton suggests in his original paper that teacher outputs contain something like he called a dark knowledge, capturing additional information about the training example. So this is quite exciting method. It worked quite well, even in surprising performance, and it's great for low resource tasks because basically you don't need a label data. You just need a large amount of unlabeled data in order to get BERT output distribution. And by using this distribution, you are training the student. Okay, so here you can see a few actually recent models that were based on distillation, which basically distill knowledge from BERT into a similar neural net like BERT. So in order, of course, eventually to learn a more efficient, a more compressed version of BERT. So, for example, if we look on the second batch of performance, the distill BERT from Hugging Face, you can see it's 50% more compression rate compared to BERT, and even 2x gain in speed up, and with only less than 3% in glue benchmark, which is a famous 11 task benchmark for NLP. So you can see that it's actually very efficient, and it's actually very popular. I think it's more than BERT. People are using distill BERT in production. But you also can see other models that reported in recent papers. If you go to the other side of the graph, you see, for example, Tiny BERT, which is actually only 14% compression rate compared to BERT base, and almost 10x speed up with less than 2% on glue benchmark. And again, all these numbers actually were taken from the original papers. But you can see that with distillation, you can get very efficient optimization and compact representation of a much smaller BERT. So as we just noticed, we have very nice compression gain with a distillation version of BERT with a similar structure. And the next question that we can ask ourselves, if we can do more. So for example, distill BERT into a much simpler network like LSTM or CNN, which is actually can be more than 100 times X efficient in memory size, or even to a much simpler network like something like continuous bag of words, which is basically something like an average of word embedding or some internal word embedding representation. It's very, very, of course, efficient in terms of memory. It can be even more than 1000x compared to BERT. It can be something like 40K or even 80K parameters size. So it's much efficient, and the question is, yes, if we can basically do it. So the answer, just to do a spoiler, is yes. But of course, there's some limitation, and I will demonstrate by 2 examples. What are the limitations? So I will start with name entity recognition example. As you know, it's a widely used information extraction task in many industrial applications. So ramping up on a new domain, if you want to implement on new domain, it's of course difficult, because you don't have a lot of unlabeled data, and often not good enough for training a specific model with good performance. So one option is you can hire a linguistic or data science. You can invest a lot of resources just to get the labeled data and train your model. And this is more or less preferable solution. Of course, you would like to, as I showed in the slide, the advantage of BERT is that BERT is great with low resource scenarios. Remember the transfer learning advantage. So you actually can take a small amount of unlabeled data and use it for BERT. But again, if you're going to work with BERT, you still have the challenge in going to production and actually implement it for inference. As we know, if you are targeting your edge device or even on your server. So this is a challenge, and one solution can be distillation. So, okay. So specifically for name entity recognition, what we see here is results of a benchmark that we did on Core NLL 2003. This is a very common benchmark for NER. The diagram shows accuracy versus number of labeled samples from your training data set. And the three bars represent performance accuracy for BERT, which is in blue, dark blue, distill LSTM, which is LSTM dot distill his knowledge from BERT, and also the yellow bar is the distill CNN, which is a very simple, again, a simple CNN architecture that learn or distill the knowledge from BERT. I remind you that distill means that we train a small model and utilizing the unlabeled data via BERT. As you can see, for low resource, and you can even see that for 150 samples, even the distill LSTM even outperform BERT. And when we go up to 3,000 sample, BERT has some advantage, but in general, I can say that the results of distillation from LSTM or for IDCNN was actually on par with the BERT performance. And just look on the table below, you can see the kind of the average compression rate and speed up that you get with distill STM and distill CNN on CPU. And of course, this is if you're considering going into production, basically, and you don't have enough data, you can consider moving to a much more simpler architecture like LSTM or CNN. And the next example, showing more extreme distillation. Basically, it's for a text classification task. So what we see here is accuracy for 4 different popular text classification tasks. The first one, age in news, 6 emotions from there, IMDb and STS2. Actually, STS2 is part of the GLUE benchmark. we presented 3 different classifiers. We see BERT in blue. We see the distilled LSTM in light blue, and the distilled CBOW, actually, which is the very simpler architecture. You can see that it's 1000x efficient in compression rate compared to BERT. As you can see, first that for those, the LSTM is not far. The distilled LSTM is not far from the BERT results for all the 4 data sets. If we look on the CBOW, you can see that for at least the 3 data sets, it's actually not bad. It's even less than 2% compared to BERT. And it's actually quite amazing because you actually can use a much efficient and very efficient, ultra efficient model and get same performance as BERT. By the way, all the graph here is for low resource data set, so it's several hundred samples per data set. It's not the full data set. I think it's less practical to have 1,000 of label data in practice in the industry. So you can see that LSTM is for sure competitive. Specifically for STS, we have more than 5% degradation, and of course, again, BERT of course is the reason is that BERT is of course has its advantage, is have a very good capability to generalize, but for specific data sets, it's still possible, even with a very small model, to get on-par performance with BERT. And as we know, and has been actually tested in many papers, BERT is quite redundant in specific tasks. So I really recommend to also to evaluate per task and to see what is your performance compared to BERT. So kind of to summarize the takeaways that we actually demonstrated here is basically compact models perform equally well as pre-trained language model in low resource environment. This is for sure. And pre-trained model, I mean a smaller LSTM, and in some specific cases even LSTM or CNN. Just to give some practical tips for those of us that are actually are working with BERT and would like to go into production with BERT. So I really recommend first on your data set, on your specific task, first of course, set some, test some simpler classifiers, your baseline. It can be even something like, of course, if you have test data and training data, you can run something like TF-IDF or with logistic or something very simple. Then you can fine tune, of course, with using a pre-trained distilled BERT or BERT on your task. We have the excellent library from Hugging Face, and you can download pre-trained models and fine tune quite easily. You have many tutorials how to do it. Then if you have a high resource, if you are lucky and you have high resources of label data, I guess you can go with distilled BERT or any other compact pre-trained models like tiny BERT or mobile BERT into production. So I think this will be efficient enough. If you have also the computing limitation, you can go with smaller BERT. If you have just low resources, if you're low resources in your labeling data, and you also have you need something that is very efficient, you can try to distill BERT into LSTM, CNN, and even CBOW. You will be sometimes surprised that you can get very high performance just by distilling BERT knowledge into a smaller representation. So eventually you do your training with BERT, but when you go to production, you actually distill the knowledge from BERT into a smaller model that is targeting your production. So I really recommend you to test your models in your specific task. Sometimes it can be very efficient. It's also a research track how do you know in advance what will be actually efficient for distill BERT compared to just using BERT. So again, this is still an open question, and basically this is the next slide. This is something that I would like very much to promote. In November, as part of EMNLP, we're going to have a very exciting workshop that is going to be focused on what it's called sustained NLP, but the target is to demonstrate simple and efficient NLP for the industry. And it's quite exciting because this is the first time that we show the research community actually are working quite hard to work on efficiency problems for the industry. So what we're going to have in the workshop, and by the way, the deadline for sending papers, and also there is a shared task as part of the workshop that trying to compare very efficient methods to BERT. So I encourage you and also the research community to send your work that's related to efficiency and also participated in the shared task. There is going to be two main issues. One is, of course, related to efficiency, the size of the models, and also regarding the amount of data that you have to train And the second one is about, it's very similar to what I presented so far, is focusing on the complexity of BERT, and actually how you can actually get a much smaller model, neural net, that provide the same performance as BERT. I think we have some more time, so we can also, so this is kind of concluding the more the efficiency part of the agenda. And I just go, and there is kind of many work related to efficiency, and just gave a very short overview of the most popular methods. I encourage you again to watch the workshop and get more results, and are going to be published in November. So I'm quite excited about that. Okay, regarding the second challenge, and I'm not going to have a deep review of the challenge. I'm just going to maybe show you demonstrate one application that actually tried to handle the challenge of low resource data. And it's also called extensibility. Basically, you have a new domain, you already trained your models, but now you have a limited amount of data for your new domain. So, and of course, with minimal supervision. So how do you actually learn or adapt your models into the new environment? So let's see, just to capture the NLP status today. So we know that data science team build a deep learning model to solve specific NLP tasks. Those are quite data hungry. Deep learning models must be fed with a large amount of annotated data, which of course it's time consuming and also require a domain expert and a specific skill to get the data ready for training. And of course, we know if in the industry that the business environments are dynamic and very complex, and make it impractical to collect and label enough data for each scenario in a given domain within a practical time frame. Even if you have BERT, you still need to train it for a specific domain and do all the process. So although much kind of progress has been made in deep learning for NLP, we know that the current methods of machine learning hold back a lot of adoption of NLP-based deep learning in the commercial environment. And this is something that also the research community is working quite hard to understand how we can actually deploy models in different environments, I can say with zero-shot learning or a minimum amount of data for training. And this is and what I'm going to present next is a specific application that targeted for a non-machine learning expert, a non-NLP expert, that basically allow to scale and adapt models to new domains by learning from in-domain data with just small amount of labeled examples. So it's called APSA, which means aspect-based sentiment analysis. And I will demonstrate in a minute the application. I will try to also to show you the UI. So for example, you have the following sentence: the owner is super friendly and service is fast. APSA is basically three tasks. So the first one is to extract aspect terms. The second one is, in this case, is owner and service. The next task is to extract opinion terms and there's, of course, sentiment polarity. And the last task is basically to try to find the sentiment polarity toward each specific aspect. So, so basically, this is a more fine-grained task of sentiment extraction, not just give the polarity of a sentence, but also extract the main aspect and opinion toward those specific aspects. What we see here in the bottom is basically the screenshots from our application that we released. This is an open source, and I can give, in the next slide, I will give you the link to our library, and also it's part of Azure, Microsoft cloud service. And what we see here is this is an example from more than 10,000 unlabeled restaurant reviews from TripAdvisor. The system extracted the aspect automatically, just given by just looking, by just analyzing the data, it's automatically extracting the aspect within those reviews in an unsupervised manner. And then the extracted aspects are represented in the what you see in the x-axis. You see the list of aspects that were extracted, like food, pizza, meat, drinks, and other. And what you see here also is the green bar represents the count of positive sentiment towards specific aspect, and the red bar represents the count of negative sentiment towards a specific aspect. I will try to demonstrate the application. Again, I will try to go into basically what you have to do. And sorry, I'm just trying to share, maybe let me know if you can see.
Seeing your desktop right now.
Yeah, I'm trying to share with you the CSV file that actually represent those 10K examples.
It's on screen, you should enlarge it.
Okay. So basically, it's very simple. So what you have to do is prepare, again, since it's unsupervised, you just have to prepare the examples, the unlabeled examples. And as I mentioned, those were taken from TripAdvisor, more than 10K unlabeled examples. Each row is actually an example from a review. And that's it. Now when you have the CSV file and you run the application, I will go now to the application. Let me know if you can see the application right now. I'm also sharing it in the same screen.
It's still full screen with Excel.
Still Excel? Let's wait a few seconds.
No change.
No change. Okay, let me.
There, I see it now.
Okay, great. So basically, it's a very simple UI. You just inject the, I'm not going to do it right now because it will take time to the analyze, but as I mentioned, it's unsupervised. So you don't have to label any data. You just have to provide a CSV file through the extract lexicon bar. And then the output of the algorithm is basically first the aspect lexicon. And actually, I already run the APSA model. So you can see those are the aspect lexicon that were extracted from the data set automatically. Those are the top 13 aspects that extracted from the data set. You also can, if you want, again, you can edit specific terms, aspects, you can delete aspects, you can expand, you can also add new aspects if you want. But those aspects, again, those are proposed by the APSA app. You can also have those actually recommended. The alias was recommended by the APSA, but you can also add more aliases for those specific aspects. As you can see, aspects, of course, this is TripAdvisor restaurant. You can see foods, desserts, salads. Actually, it seems to be working quite well. And then the APSA also extract the opinion that's related to those aspects. You can see the list of opinion like tasty, flavorful, tangy, delish. And you can see that they are quite related to the specific domain of restaurant. Also, in this case, if you want, you can edit, you can exclude some of the opinions if you want. And the last step in working with the APSA is running it on new data. And what you will see basically is the analysis. So this is actually the results of running the APSA on new data. And now you can see the statistics of the positive and negative opinion towards specific aspect in your data set. You can also, if you're going, basically you can hovering on specific bar, and you're supposed to see an example. I'm not connected to the system, so you actually cannot see the example. But on the bottom, you should see an example for the sentences that related to positive and negative aspects related to drinks. Again, so this is the APSA application, and we'll go back to the presentation mode.
Actually, let me ask you one of the questions that came in. How does this work about this specifically? How does it work with negation?
Yeah, it's a good question. It's less robust to negation. What we are currently working on is a second generation of APSA, which also will include BERT, and will give much more attention to syntactic information. So will be much more robust to negation. This specific application, this is the third generation, is less robust to negation. Yeah, but again, also the model is not based on BERT, is based on some extracting dependency syntactic information from the sentences and doing some bootstrap in order to extract the aspect and the opinion. So the next generation will be much more robust to negation.
You know, if you don't mind, there are a few other questions about the APSA portion. There are quite a few questions, but let me pose these to you. One is about your definition of aspect, different from the definition that a linguist might use about verb categories. What's your short definition of aspect?
Basically, aspect is a kind of, let's say, very important entities that related to a specific domain. So it can be, if it's in the restaurant domain, it can be the service, it can be the waiter, it can be the restaurant name. So it's kind of a noun that's related to very specific entity in the domain, real, of course, entity in your domain. And you, of course, need to have a very good aspect recognition model in order to extract the aspect. So you actually need some of course, an example to extract the aspect. But we noticed that those are quite also very syntactic dependent. So once you have some general representation of aspect, you actually can generalize well to other domains. So you can take also syntactic features that you learn in one domain to an unknown domain. So they kind of agnostic to domain, although of course the semantic information is not agnostic. Of course, it's very different in different domains.
Well, speaking of that, perhaps, what about aliases, or we could call it co-reference, maybe multiple ways of describing the same aspect?
Yes, correct. So we have under the hood, we have some algorithm that doing the co-ref resolution. So they are trying to suggest similar aspects and try to unify similar aspect to one entity. And this is also based on now in the second generation. This is also based on BERT. And in our library, we also have an example for co-ref resolution that we actually deploy as part of the APSA solution. So you can get more information on this in our website.
Do you want to continue?
Yeah, so I continue. So let me see, I will share the presentation again. Okay, so this is actually the last slide. Basically what you can go to our open source library called NLP Architect to get more information about APSA. There is a very nice documentation. Also, we have the same model as part of Microsoft Azure. If you want, I could send you the specific link for the application. You have a very nice tutorial on Microsoft Azure that demonstrates I actually activate and train the APSA solution. And again, we are working on the second generation. Currently, what is nice about and we got very nice feedback from not customers, but again, everything is open source. So there is no kind of license and services. Everything is available. All the code is available as an open source. So the advantages is that first, it's an aspect based, so enable us to extract much more fine-grained information regarding the sentiment. It's a kind of unsupervised approach because we don't need label data in order to fine-tuning it to a new domain. But of course, there is a limitation of performance and things like negation that can be an issue. And of course, it's explainable because when you extract aspect and opinion phrases, actually that produce some sentence level score, and that you can actually explain why you got this specific opinion for a specific aspect. Again, so this was actually the last slide. So we can now, maybe the last slide is, of course, the thanks. Let me go to the last slide. So again, thank you all for listening. And I hope it's kind of, you will try to go over the recent research regarding efficiency and data extensibility for deploying NLP deep learning in production. And I'm looking forward to get your feedback. Please send me questions. Again, we can have also in this session a few questions, but feel free to shoot me some emails or on my tweets, LinkedIn, question related to the work that I presented today. So thank you very much.
Thank you, Moshe. We do have quite a few questions right now, which we'll go through. But first, we have requests for your slides. Will you be able to provide those?
Yeah, sure. Yeah, sure. If it's okay, I will send it directly to you, and you can share it.
With any other links as well. So I'll start with questions, but again, if you would like to ask your question yourself and be voice enabled to do that, please chat to the panelists only and let me know, and I'll enable you, or use the Zoom raise hand feature. Let's start with a question from Yi Shang Kao, who asks, for thieves of Sesame Street, how do you fine-tune BERT without label data to produce pseudo-labels?
Give me 1 second. I will just try to open the Q&A session to view the Q&A.
So that's the top question.
Yeah. Okay. How do you fine-tune BERT without? So again, okay, so with thieves of Sesame Street, basically what they did, they had some kind of BERT service, a kind of remote BERT service that actually, if you send, for example, think about it as kind of you're doing, you have a service for sentiment extraction, and you have some remote service that you can send to this remote service and get reply, which is the positive or negative answer. So by doing that, you're actually collecting pseudo labeling data. So if you are running several hundreds or several thousand examples via this remote service, basically you can get enough pseudo labeling data with very good quality, and then you can use this specific data in order to train your own BERT on your premise. So, and it's turned to be that just using the pseudo labeling data is enough for doing the fine tuning of your BERT or a much smaller BERT in your actually premise. So you don't really need to get label data. You have the pseudo labeling from the service, and this is exactly what they demonstrated in the paper.
Right, you have a question from Hamad Somru about ML. I assume that's just machine learning or reinforcement learning as being more efficient accuracy-wise for model training. I don't think it's either or, but it's questions for you.
For sure, for NLP, there is some work regarding reinforcement learning, but I think the most effective methods are based on, of course, using a method like the training BERT and the gradient descent method, and less reinforcement learning related to NLP. I remember from the last ACL conference, there were some work related to reinforcement learning. It's quite exciting, but I think this is still on research. Not yet good results compared to the well-known method that we are trained today, the GPT and BERT models.
Maybe,
but it's very promising.
Maybe more reinforcement learning as we have more conversational AI, but who knows?
Correct, yeah. Maybe it's more related to that, conversational AI.
A question from Yuri, can you do effective transfer learning with distilled CNN?
Yeah, actually this is, I think one of the slide that I showed for the text classification actually show the CNN. I'm not remember if I didn't include the CNN, but I can send Yuri the CNN results. It's actually comparable to LSTM.
All right.
It's very much in performance comparable to CNN, to LSTM, but something like 1% or 2% from BERT base in specific tasks. So yes, it's possible to do also CNN.
A question from John, any tips or advice on natural language processing for clinical text data?
Yeah, so first what I recommend is to go into the Hugging Face repository. You have more than, they have more than 2,000 models. They also have some specific pre-trained models for biometric. And I suggest that you would start from something like a more BERT pre-trained model. And then if you are trying to extract information like specific entity, you actually can follow, also do some NER extraction using BERT. You have very good tutorial. You can search for tutorial regarding name entity recognition with BERT. So you can start with a pre-trained BERT. I think they also have distilled BERT. So I think they are quite robust for clinical data. So you should start with something like it's more specific to the clinical domain. Yeah, this is my advice.
Yeah, someone put in the chat, Said Mehrabi, Hugging Face has clinical Albert too.
Oh,
okay.
Yes, good. Yeah, so you should start from that. Yeah, definitely.
So Arthur Henderson asked, what machine learning frameworks do you recommend for trying various NLP language models?
There is one answer. The Hugging Face is the I think the most popular, and I think that so they did amazing work to do all the BERT training and using pre-trained model. Amazing work and very simple to go to production and experience with BERT. So I really recommend to start with Hugging Face.
Yeah, I'll put in a plug, maybe not an answer to this particular question, that our September 10th meetup is going to feature Weiwei Guo from LinkedIn talking about DText, which is a framework for deploying certain natural language processing functions. So there you go. We have a question from Ken Felling. So in a way, you're using BERT to label the data to train the smaller model on. Okay, you have an answer for that?
Sorry, what is the question? I don't see the question.
I'm not sure the question is well formulated. You're using BERT to label the data to train the smaller model on. That's not quite what BERT is about. For training smaller models, you can do last mile type of training of stuff that's in BERT already. Do you understand the question?
No.
Let's just move on.
I think I'd recommend you to look on TinyBERT and MobileBERT. They actually deploy distillation in a very effective way, and they not just learning the hard labeling. As I mentioned, this is not just about the labeling data, but you also can distill internal representation like the embedding and also the attentions and also the logics. And I recommend you to look on MobileBERT, which is quite effective. They actually did distill all those features. So again, and they got very state-of-the-art results.
You know what, Ken Felling, if you have a microphone handy, I just voice enabled you if you'd like to try to restate your question. I'll give you a couple of seconds. Well, all right. Let's move to the next question. Can you discuss how or if the distillation approach could be used to enable multi or cross-lingual NLP applications?
Yeah, so there is a great work by Kevin Clark from Stanford that he did actually cross-lingual NLP application with BERT. So I think that those are kind of, and I think he's one of the model that he were actually trained on cross-lingual NLP application. He did also some multitasking using distillation with great performance. I can maybe send you the link to the paper.
What was the name of the author?
Kevin Clark from Stanford.
Yeah, I might be able to bring that up. So we had another question. So the intuition of teacher-student model, I guess the implication is that BERT model has higher accuracy for tasks for unlabeled data, so it could still train the less heavy student model to get better performance. Does that make sense to you?
I think if you can think about that, Basically, what the smaller model is using the unlabeled data in order to get a much higher volume of data for training. So by getting more data, so BERT actually cannot improve by just getting his own labeling. But the smaller model, if he can put some high end on some large data set, actually annotated by BERT, I think is getting more data, actually getting him much more closer to BERT and actually close the gap for a specific task. And there is a few other papers that show that basically if you get more data for a smaller model, you actually can get comparable results to BERT for specific tasks. The big advantage of BERT is more for syntactic tasks. But if you're looking for text classification, which is more topical, more semantical, BERT is quite redundant. So basically, you can get more data for your smaller model and get close and close the gap with BERT. So I think this is more the intuition on what you do with the distillation.
All right. This question from Brian: how does this perform on sarcasm or talking around a subject? I'm guessing we're back to the APSA here, but sarcasm.
Yeah, it's not trained for sarcasm. It's currently to extract aspect. It's a different task. The question, if you are doing text classification, so maybe it's not related to APSA. So if you can try it also for your specific task and domain. So I guess please follow the steps. So try to run BERT on this specific task, and then try to use distillation into a simpler model and evaluate your performance. No, I think it's less related to APSA.
Let's see, we have a question. NLP Architect seems to support only TensorFlow 1.x. Are there plans to support 2.x?
We have a plan. This is probably going to be in a few months. Our focus is going to be more on efficient models. If you have, if you have specific requests, please send it to our GitHub, and we will reply.
What is the GitHub?
I can say I will put it in the presentation. This is it's called Nirvana. I will send it the link as part of the slides for everyone. But you can look for NLP Architect by Intel, and you will see the GitHub.
Let me see. I'll see if I can find that in a second. So Victor Pekar asks, does your system for APSA extract multi-word aspect terms, for instance, customer service?
It's possible. Currently, it's not supported. This is a part of a version that we don't have as an open source. So the current method is not supporting multi-word aspect, but we're going to release when we release the second generation, we're going to support also multi-phrase for aspect. Yes.
All right. Kieran O'Sullivan, thanks you for a great talk. Does the process of distillation work if you have new words in your data set which were not present in the vocabulary which the large BERT model was trained on?
Again, since it's basically what you're using BERT to annotate new data, so it's supposed to work because BERT can handle out of vocabulary words. Basically, it's quite robust even to out of vocabulary words. So if you have unlabeled data and some of the words are not part of the training, it should be okay. It still will have quite high accuracy on your unlabeled data, even if you have out of vocabulary words.
All right. Pat Malloy would like the Azure link.
Yeah, sure, no problem. I will send it to you and the tutorial. I will include it in the presentation.
All right. Jade asks, will the relevant research you referenced be linked anywhere? I guess you have a lot of links in your slide deck.
Yeah, when you have the presentation, I have many links that you actually can go to and see the papers. And of course, yeah, but of course, I will add more following your comments.
All right. Gutam asks, to use a distilled model, do I have to do the distillation myself, or can I download the Distilbert model and just fine tune that on my data set?
Yeah, sure. You can download, you don't have to run the Distilbert yourself. You can download the pre-trained distill model and actually fine tune on your data. You don't have to distill yourself.
All right. Jade asks, what would you recommend as a method for topic detection?
For topic detection, so the question is, what do you mean? It's more for, I'm not sure I understand. It's more for classification of your documents, or
Well,
just extracting?
Is similar to the aspect detection that you're already doing.
Okay.
For general.
Okay.
Topic detection would be, typically an LSA type of thing, the older school way of doing that.
Yeah. So actually, you can use the aspect that is part of the APSA to extract the main topics. If you are targeting topics that related to for aspect in your domain, so it can be good, maybe good choice to use the APSA for that. But I guess there is other methods to extract topic based on frequent and other methods that are much more efficient. So it really depends on the task.
Yeah.
And the domain.
All right. We had a question from Saeed Mehrabi. Thanks for the presentation. He had the same speed issues with BERT and Distilbert on deployment. On text classification with Distilbert, how large was your text file? Did you make any changes on the model configuration files, specifically the sequence length, 512 or less? Server specs, did you use CPU versus GPU? There are a bunch of questions there.
Yeah, so again, you also can send me some questions through the links. Of course, it depends on the data set. For example, with IMDb, I was actually trained with the maximum, which is 512, which is the maximum for Distilbert. But again, and got very good performance, more than 90%, accuracy, F1. So it really depends on the data set. For example, for STS, it was less than 64 tokens per sentence. So basically, you can try. It depends on your data set. So you can try with, you can start with 64 and then you can go up to max of 512, but you can have some issues regarding probably memory and something like that. But I recommend you to start with a small amount of tokens per sentence before you crash.
Yeah, server specs, CPU versus GPU. These are kind of detail level questions.
Yeah, you can do both, I guess.
Yeah. All right. Yishang Kao asks, when applying these pre-trained big models to commercial product settings, how do you estimate the R&D schedule specifically for developing a good enough model in the product? That's not a technical question. It's an implementation operationalization question.
Yeah, I think I have to say that I less agree with the fact that accuracy is the most important metric to evaluate your algorithm or your model in production. You just look on just 2 weeks ago, we had the ACL, and the best paper was actually more about testing your model in production. It's kind of a checklist to not just look on accuracy, but also look for things like negation, out of vocabulary words, a long list of tests that you have to do in order to find out your quality, your model actually can be efficient in production. So I think this is something that we see as a trend in the NLP community. Many are focusing on not accuracy and trying to provide more kind of software like test mechanism in order to evaluate your models. So I really recommend, by the way, to look on their paper. It's won the best paper for AICL 2020.
I'll add
really,
that as a long-time consultant in commercial and implementation settings, the question that one should be asking is not accuracy, but suitability for task.
yeah.
Does it give you good enough? I believe in good enough results.
Yeah. So the word is sustainable NLP. This is the new word to evaluate models in production.
We have one more question that's been answered. I hope I didn't miss any in the chat. That question from Jade is, let's see, generally if you have a sentence or block of text, how do you determine the topic of discussion, especially if you have multiple sentences with different topics in one block?
Again, the question is if you do know the topics in advance, so you can actually have something like a multi-class classifier. So this is also something that is you have very nice tutorial based on Hugging Face how to do multi-class classification. If I understand correct the question. So if you have if you know the topics, you can do some classification.
But this is maybe if you don't know the topics, but here the answer goes back 60 years to the late 1950s. The topics are based on statistical frequency of multi-word expressions, right? And you know, that still works very frequently.
Yeah.
And not just statistical frequency, but a TF-IDF type of thing. What are the standout frequencies? So, and that's not a BERT type of question, is it?
Yeah, I guess also the latest GPT-3 actually demonstrated quite nice shorting learning for new topics. So I think this is going to be quite exciting field of research in the upcoming months. So again, maybe it's related also for that.
All right. Well, last chance, any other questions from attendees? So seeing none, we'll wrap up here. Thank you very much, Moshe, for participating. We will have the videos posted at the NLP XING YouTube channel. That should be very soon. And then Moshe will provide his slides and we'll distribute that as well as some other resources. And then the next meetup will take place on the 25th of August. Okay, one last question in under the wire from Alex. Is there a list of recommended KPI, that would be key performance indicators, accuracy and so on, that you base on? He's asking to build on the last question. What do you look at if not accuracy as the top metric? Okay,
so this is exactly what the paper is about from ACL. They also released an open source that you have a checklist for specific tasks. And basically the checklist offer other KPIs to measure your models, not just based on accuracy. Please go ahead and look for the best paper in ACL 2020. You will, I think this is something like, it's called checklist for NLP models, something like that. So it's really exciting to see that the research communities are focusing on real NLP in production.
Great. Well, I will start my video again. Thank you very much, Moshe, for the presentation today. Sure. You had a lot of questions. That indicates a lot of interest. And so we'll look forward to the materials that you'll provide, including the slides. And you can look for the conference Moshe mentioned taking place in, I think it was November, and he and I will both be giving presentations at John Snow Labs NLP Summit taking place online. And then I hope you will attend future meetup programs. If you are coming from General Assembly, then you'll need to register with one of the meetups. It can be NY-NLP in order to get our notices. Thanks everyone, and see you next time.
Thank you.